students, welcome to all in the physics lecture. Myself Prayoge ma'am from physics department. We had completed the chapter electric current through conductors. Now in this session we are going to start chapter number 9, that is electrostatics. So what do you mean by electrostatics? Electrostatics deals with static electric charges. Static means steady electric charges. Okay, so electrostatic, it is mainly the study of static electric charges, then force between charges and effects produced in the form of electric field and electric potential. Okay, so electrostatic, it is mainly the study of static electric charges. Now in this chapter we will study the concepts related to electric charge, like basic properties of electric charge, then Coulomb's law in scalar form, vector form, relative permittivity, principle of superposition. So all these concepts are related to electric charge. Then what is the definition of electric charge? Electric charge is the physical property of a matter that causes it to experience a force when placed in an electromagnetic field. Okay, so the force experienced by a particle when placed in an electromagnetic field, and this property is known as electric charge. Okay, electric charge means the force experienced by a particle when placed in an electromagnetic field. Now electric charge may be positive or negative. So there are two types of electric charge, positive charge and negative charge, and it is represented by the letter capital Q or small q. Okay, electric charge is the basic property of elementary particles of which matter is made up of. Okay, so electric charge is the basic property of elementary particles. Now what do you mean by elementary particles? So elementary particles means like proton, electron and neutron. Okay, as we know that proton is considered to be positively charged, electron is considered to be negatively charged and neutron is considered to be neutral, that is it has no charge. Now next point is basic properties of electric charge. There are four basic properties. First, additive nature of electric charge. Second is quantization of charge. Third is conservation of charge, and fourth is forces between the charge. Okay, so the first property is additive nature of charge. Okay, now additive nature, the first point, the total electric charge on an object is equal to algebraic sum of all electric charges distributed on different parts of the object. The total electric charge. Now consider this is an object. Okay, consider this is an object and the charges distributed on this object. Consider Q1, then Q2, Q3 and Q4. Okay, so these four charges are distributed on this object. Then the total electric charge on this object, capital Q, is equal to, capital Q is the total electric charge on an object, is equal to algebraic sum of all electric charges. Algebraic sum of all electric charges, that means Q1 plus Q2 plus Q3 plus Q4. Okay, so this is the first point in additive nature. The total electric charge on an object is equal to algebraic sum of all electric charges distributed on different parts of the object. Okay, second point, if two bodies have equal and opposite charges, then the net charge on the system of two bodies is equal to 0. If two bodies have equal but opposite charges. Now consider this is the first object and this is the second object. Okay, now the charges distributed on first object, consider these are the charges Q1, Q2 and Q3. Okay, these all charges are positive. Okay, plus Q2 and plus Q3, and on second object the charges distributed on second object minus q1, then here minus q2, and here minus q3. Okay, so if two bodies have equal but opposite charges, now on first object charges q1, q2, q3, and on second object similar charges, that is q1, q2, q3, but opposite. Okay, here positive charges, and on second object there is a negative charges. So if two bodies have equal but opposite charges, then the net charge on the system of two bodies is always equal to 0. Net charge, so q is equal to q1 plus q2 plus q3, and the charges on second object minus q1 minus q2 minus q3. So net charge on the system of these two bodies is always equal to 0. Okay, so net charge on the system of two bodies is always equal to 0. Now third point in additive nature, if we compare the additive nature of electric charge with that of mass, then the first point in mass, the masses of the particles constituting an object is always equal to positive. Okay, as we know that if we take the masses of any object, then it is always equal to positive. But in electric charge, the charges distributed on different parts of object may be positive or negative, because as we know that there are two types of charges, positive charge and negative charge. So charges distributed on different parts of the object may be positive or negative. Okay, now second point in mass, total mass of an object is always positive. If we add the masses of many objects, then the total mass is always positive. Okay, but whereas in electric charge, the total charge on the object may be positive, negative or 0. If we add the positive charges, then we get the total charge is positive. If we add the negative charges, then total charge on the system is negative. And if we add the opposite charges, that is positive and negative, then the resultant charge or total charge is equal to 0. So total charge on the object, the total charge on the object may be positive, negative or 0. Okay, now the next property, second, quantization of charge. Now what do you mean by quantization? During charging process, an integral number of electrons can be transferred from one body to another body, then this property is known as quantization of charge. Okay, quantization means an integral number of electrons can be transferred from one body to another body, and this property is known as quantization of charge. Okay, means number of electrons can be transferred from one body to another body, and this is known as quantization. Then the magnitude of charge on an electron, the value of charge on an electron is 1.6 into 10 raised to minus 19 Coulomb. Okay, this is the standard value. The magnitude of charge on an electron, it is always equal to 1.6 into 10 raised to minus 19 Coulomb, where this C stands for Coulomb. Okay, C stands for Coulomb, and this is the SI unit of electric charge. Okay, this is the SI unit of electric charge. Always remember, Coulomb is the SI unit of electric charge, and the standard value of charge on an electron is 1.6 into 10 raised to minus 19 Coulomb. Okay, and charge on an object must be integral multiple of plus minus E. Why here plus minus E? Because charge on an object can be increase or decrease in multiples of E. So here charge is plus minus E. Okay. Now next property, conservation of charge. Now we have already studied the law of conservation of energy. What is the law of conservation of energy? That is, energy can neither be created nor destroyed. It can be converted from one form to another form. That is, energy is always conserved. Okay. Similarly, conservation of charge. In any physical process, charge may get transferred from one part of the system to another part, but total charge in the system remains constant. Okay, law of conservation of charge is, in any physical process, charge may get transferred from one part of the system to another, but total charge in the system remains constant. So we can say that for an isolated system, the electric charge or the total electric charge is always conserved. So this is the conservation of charge, that is, charge may get transferred from one part of the system to another, but total charge in the system remains constant, or it is always conserved. Okay. Now next property, that is fourth property, forces between the charges. Okay. Now we know that unlike charges attracts each other and like charges repel each other, because there are two types of charges, that is positive charge and negative charge. So if opposite charges, then they attract each other, and if the like charges, then they repel each other. For example, now consider the first diagram. Suppose this is the rubber rod. Okay, and on rubber rod there is a positive charges, and here second rod is glass rod. Okay, and here on glass rod there is a negative charge. First rod is rubber rod and second rod is glass rod. The charges distributed on this rubber rod are positive and the charges distributed on this glass rod are negative. Then, and in second figure, consider the two rubber rods, that is, this is the first rubber rod, and again here second is also rubber rod, but the charges distributed on these two rods are similar, that is positive charge. Okay, this is also rubber rod. Now in first figure, this is figure A and this is figure B. Okay, now consider these two figures. In first figure, this is the rubber rod and this is the glass rod, and the charges distributed on this first rod is positive and here the negative charges. That means here the opposite charges, so they attract each other. That means here is force of attraction. Okay, in first figure, force of attraction, because unlike charges attracts each other. And in second figure, both the charges are similar. Okay, positive, here also positive. That means like charges repel each other. So here is force of repulsion. Okay, the force is force of repulsion. Okay, so this is the fourth property, that is forces between the charges. Okay, so these are the four basic properties, that is additive nature of electric charge, then quantization of electric charge, conservation of electric charge, and fourth property is forces between the charges. Now next point is Coulomb's law in scalar form. Coulomb's law in scalar form. Coulomb's law in scalar form. Okay. Now this is a very important question as per your exam's point of view. Okay. Now consider 2 point charges. Okay. Consider 2 point charges Q1 and Q2 separated by a distance small r. Okay, consider 2-point charges at rest with respect to each other and separated by a distance small r. Then what is the statement of Coulomb's law? If 2-point charges are separated by a distance small r, then force of attraction and repulsion, okay, force of attraction and repulsion between 2-point charges is directly proportional to product of magnitude of 2-point charges, and it is inversely proportional to square of distance between them. Okay, and it is inversely proportional to square of distance between them. Now distance between them, that is small r. Okay, square of distance between them, that is r square. So first point is the force of attraction or repulsion between 2-point charges is directly proportional to product of magnitude of 2-point charges, that is Q1, Q2, and inversely proportional to square of distance between them. So the statement is the force of attraction or repulsion, between 2-point charges, is directly proportional to the product of magnitude of 2-point charges, and inversely proportional to square of distance between them, Okay, this is the statement. It is a very important question. Okay, so consider this is equation 1 and this is equation 2. Now from equation 1 and 2 we can write F is directly proportional to Q1 Q2 upon R square. Okay, from these two equations we can write F is directly proportional to Q1 Q2 upon R square. So finally we get F is equal to K into Q1 Q2 upon R square. So this is the Coulomb's law in scalar form, that is F is equal to K into Q1 Q2 upon R square, where K is constant of proportionality. Okay, now consider these two figures. Now for first figure, the force between 2-point charges will be attractive if both the charges are unlike, that is one charge is negative and another charge is positive, then the force between 2-point charges will be attractive force. Okay, so for first figure, first charge is negative, another charge is positive, then there will be force of attraction. Now for second figure, the force between 2-point charges will be repulsive if both the charges are similar, that is both the charges are positive or both the charges are negative, then there will be force of repulsion. Okay, now in second figure both the charges are positive, therefore there is a force of attraction between 2-point charges. Okay, in next lecture we will study the relative permittivity, then principle of superposition and other concepts. Okay, thank you.